Good evening, good evening, good evening. We're preparing to start. I've already started to share this within our third party tonight. So it is going to be recorded on YouTube. If you haven't followed us, DCI Education Group is where it's at. Now, this is us continuing of our chapter 6, chemistry and chemical safety. You will see me going between two different PowerPoints. Let me make sure. Pause them. Okay. All right, so here we go. As I was stating, you'll see me go back and forth between two versions because I think there's still some prominent information I don't want to miss and that I want to make sure that you guys get tonight. So for those individuals that are coming in late, this is recorded. Um, and then let's begin. So yes, this is the base of chemistry, but we have also added chemical safety. So you'll start to see that in our newer version within their SEMA portal. Okay. Some of the objectives that we're going to focus on, and we have two slides of objectives. One being define chemistry and its branches. Okay. And so we're going to learn the difference between organic and inorganic chemistry, explain matter and the structure. We're going to discuss the properties of matter and how matter changes. Okay. How we use matter in every day in the treatment room, that's going to be pretty much the areas of chemistry that we're going to work with. You have very minimum of this particular chapter on the test, so it will be condensed, but it needs to still be said. I want to make sure I'm still giving you what you need. Then we're going to understand how acid, alkaline, and pH affect the skin. So our biggest component is saying it again is that pH scale. Explaining pH and the pH scale, and then explaining the difference among solutions, suspensions, and emulsions. And so based on the products that we're going to be using on our clients, they have different consistencies from solids to solutions, suspensions, emulsions, so on and so on. And so really when you're creating protocols and then um, just a diagram or a map of how we're going to get the client's skin from point A to point B using different types of products, it does help in knowing what the client prefers to work with at home, so you're not sending them the wrong thing. And when you think about this, I want you to think about deodorant. It comes in many different forms, and then also sunscreens, tanning lotions, tanning products that come in many different forms. So we may have even cleansers that come in different types of cleansers. You got liquids, you got creams, you have emulsifying solids. You have so many different types of the products that we use every day. So looking at chemistry, it's defined as the science that deals with the composition, structures, and properties of matter, okay? And how matter changes under different conditions. We always do reference for the ice and water, things like that. And you will say, Ms. Fuss, how this component right here matches with us in the treatment room? Well, we put distilled water in the steamer, okay, under compressed heat. and compress heat, we then produce steam. All right, and steam into vapors, and that's what we soften the skin with and soften the pores and everything inside of the follicles. And that steam slash heat does draw everything closer to the surface of the skin. All right, and so that's one form of chemistry that we deal with in the treatment room. So let's look at um, the either or. So organic chemistry is the study of the substances that contain carbon, okay, which allows them to burn. Okay, the study of the substances that contain carbon, which allows them to burn. And then the next bullet is all living or formerly alive things contain carbon. So organic does not always mean natural or safe. All right, organic can mean something that contains carbon, maybe something that has been once alive that contains carbon, and that falls under organic chemistry. Inorganic chemistry, being the opposite, self-explanatory, is going to be the study of substances that do not contain the element carbon, but may contain the element hydrogen. Okay, a lot of our techniques, products, and things like that will deal with hydrogen. You have hydrogen pens, hydrofacials, and things of that nature. So, hydrogen is going to be a major part of aesthetics, especially day spa aesthetics. Okay. So the study of substances that do not contain the element carbon. All right. And carbon allows something to burn. We want to do the opposite, but may contain the element hydrogen. That's something that we can look for on our study guides. Matter, anything that occupies space, takes up space. Okay, is this measurement? It can be measured, has physical or chemical properties, and exists as either a solid, a liquid, or a gas. Okay, a solid, a liquid, or a gas. We do have water as an example of that. Now, this is what I want you to definitely stick a pin in. Cones, COHNS. I never want you to forget this. Cones, okay? Our hair, skin, and nails are made up a combination of cones, COHNS, okay? These are the elements that make up us, who we are, all right? Especially your hair. Carbon, oxygen, hydrogen, nitrogen, and sulfur. And just for example, some people used to say, my hair was damaged, it's breaking off. I used sulfur A, just brought it on back together. The reason why sulfur A worked, people thought that it worked, it was replacing something that's organically the hair was made up of. And so it just came in and filled the gap. It came in and did a repair. Okay. It came in and filled the gap, and it came in and did a repair. So if you were lacking sulfur, that sulfur 8 component came in and filled in, and it probably did get a boost to the generation of more hair, skin, and nails. But that's what that comes from. And so this is what I want you guys to always remember. If something's going on with the hair, the skin, or the nails, I always go back and look at cones. And I always look at the protein. Okay. I say, okay, I need products or facial machines or facial devices that's going to help produce what's missing in the skin. And so ultimately, a lot of people will say, I'm just a product junkie. I'm gonna see if this product works, that product works. But sometimes it could be protocol where you build up what's already in the skin, okay, and then you just have to fill the gaps with your product. And you have to look closely as far as ingredients. So yes, hydrogen, we think of hydrogen, we think of hydration, we think of water. And so that is a major component of hair, skin, and nails. Like your hair, skin has to breathe. There's oxygen, okay? And when you have detox skin that is toxic skin that could use a detoxification, could use a purge, you'll find that the skin looks younger, it appears lighter, and it'll have without waste. And so a lot of times what people have going on, it could just be clogged pores, but it could just be clogged full of some of the worst things on the earth. And this person could not had a cleansing or proper cleansing in a very long time. Once again, that's your cones. And so first, I always look, how can I replace what the skin is already made up of? Okay. And of course, with these cones, then we have building blocks of protein. And so a lot of times when something is breaking down, I look at replacing what it's made up of. I'm going to replace carbon, oxygen, hydrogen, nitrogen, sulfur, which mean products that have these things in there are going to be attracted to me because I know that'll be a great repair or rescue for my hair, skin, or nails. And then I will look at always keeping a protein on deck. Okay, because you have hair, skin, and nails made up of muesli, a large percentage of protein, over 90%. Okay, and for hair and skin, I would probably use a silk protein. And then for they also have, of course, you can tell your clients to eat, make sure they eat their eggs. That's protein. You have people that'll take an egg and put it on the hair. That's protein. Okay. And so there's so many different types of protein, but just the silk protein is one that can be used as building up the skin, building up the hair. And if you're going to do it on the hair, it's a great detangler. Feel like silk. Okay. So as it's conditioning and treating the hair, it's also rebuilding something that the hair is missing. And so these elements here, I want you to always remember cones. Cones are carbon, oxygen, hydrogen, nitrogen, sulfur. So it goes down on the nerdy side of what the skin is made up of. And whenever you have skin, hair, nails not really up to par, doing what it's supposed to do, very poor treatment, not having cleansing routines, you need to go and replace what's been missing and then build on top of that. How do you do that? You look for you look for products that have those ingredients within. Okay. Atoms and molecules. I'm gonna tell you now, when we look at cones, we're looking at this stuff. I don't want you to get confused when we talk about atoms and molecules. Simply how this relates to you is the fast, rapid repair of skin. You want the skin to repair and replace itself faster. You want it to repair. If there's a tear in the skin, and as you get older, you don't grow new epidermal layers fast. And so you'll see that when you're younger, that scalp comes right on. Okay. And then that's that skin starting to repair itself. All right. It's starting to turn over. So new skin is constantly being produced. But as you get older, it takes a minute for that scalp to come up. And so that tells me that the process of producing new, fresh skin, it has started to slow down. All right. And it happens, and it's general as with age. This is where anti-aging products, ingredients, night creams, um, alkaline water treatments, some of the most expensive treatments that deals with stem cell related to the skin. This is where all of that comes in to almost trick that natural aging component into looking younger, being younger, and reproducing faster. All right. And so you'll see a lot of this in anti-aging products, which will probably say will have more cell turnover, faster cell turnover. When you hear faster cell turnover, that means that it's a product or an ingredient that this rapidly helps repair the skin. So instead of waiting a while, that ingredient starts to activate and it starts to repair really fast. Okay. So atoms and molecules goes back to some of the basics. We have protons, neutrons, electrons. You would have electrons that are always moving around. And a lot of times when you have night creams and serums, you're going to see a molecular breakdown. All right. And so sometimes creams are going to be thicker, and then sometimes creams are going to be very light and smoother. Sometimes the creams that are very light and smoother can be the most effective. Okay, I said can be. And I look for something light and creamy. It almost on your fingers, on your hand, it just feels like a cloud or just a little puff or a cotton ball. That's what I look like. That's what I look for, because when I put it on the skin, that means the ingredients are gonna go, it's gonna drive and go right into the area it's supposed to go. Okay. And so that's one thing that I look at. It's the atom and molecule, this the chemistry makeup of those ingredients. When we look at states of matter, and we are going to do, of course, water, ice, that's coming up in a little component. But let's understand the difference between a solid, a liquid, and a gas. All right. A solid has shape, volume, and weight. We can say that that's a piece of ice. Okay. It looks like a cube, or you can mold it into whatever you want to, but it's solid. It has shape. It has volume. So it's probably when you turn to the side, it's not thin. And then it has weight. Okay. You have lightweight ice, heavyweight ice, a shape, volume, and weight. Okay. So it's one structure that's solid. And then you have a liquid. It has volume. It can fill up a glass or a tub or a pool, and it has weight. Okay. Have anyone been to the aquarium, particularly ATL, or been to an aquarium lately? An aquarium. Has anyone been to an aquarium?
I haven't been,
Okay.
but I'm gonna go one day.
Cool, cool. I remember touring an aquarium in Atlanta, that the really big one, and I'm just a facts person, and I was going through the area where they had dolphins or sharks or something. I don't remember, but it was big, and they had this diagram on the wall, and it talks about the deeper you go in the ocean, how much weight that is carried, you start to feel the weight of the water. All right. And if you remember when those individuals went looking for the Titanic, the pieces of the Titanic, they went, the farther down they went, is the weight of that water, where it says they just kind of blew up. Okay. And that wasn't a laughing matter. They just kind of blew up. Well, the farther that you go down, the more weight that sits on you. And then you just, you can't take the weight anymore. So there are depths that they suggest people to say, hey, no one really should be going down past this particular area. I don't really think they know how deep the ocean is, but it has different depths. Okay, where it covers and can hold whole cities and things of that nature. It has different depths. So I do remember that, and I was very intrigued by the weight of the water. So once you're in the body of water, then you go under the body of water. The deeper you go, of course, the more weight that is on you that actually becomes resistance to you getting back to the surface. And so that was just something that liquid water, it volume, it's going to hold in whatever you can hold the water in. So it's going to have volume. It may not have shape, because as soon as you pour it out, it just goes everywhere. So it does not have shape, but it has weight and volume. And then gas, okay, have no volume and no shape. This is the steam. We use all of this Okay. And so you may start off with ice, but for us, we mostly go from liquid to gas. We'll take the water, although it has no shape, it has volume and weight, and we put it in our steamer. And from our steaming rod, at that certain temperature, it starts to produce steam, which is a gas. Okay. And that's what softens the skin and draws things to the surface of the skin that is within the pores. Okay. Let's look at states of matter. Once again, solid, liquid, and gas. Examples of a solid: ice, brushes, chair. Liquid, you got water, cleansers, and serums. Okay, that's a liquid. And then you have gas. It's steam, it's vapor, it's propane, and it's ozone. All right, steams, vapor, propane, and ozone. Okay, and so those are solid, liquid, and gas. All right, let's look at physical and chemical properties. All right, let's look at physical and chemical properties. All right, physical. Determined without a chemical reaction: color, odor, weight, and density. I want to make sure that we know the difference between these. Physical is determined without a chemical reaction. All right, so not looking at chemical reaction, has a color, has a odor, could be a color, could be an odor, could be a weight, and density. And density is a width of capacity. So that's something that's physical. And then you have chemical, determined with a chemical reaction. Okay. It may change identity, go from hot or go from cold, a rusting iron or a burning wood. This particular picture I wanted you to look at because I see it in both versions of this chapter. You have an acid and you have an alkaline. Okay. Reaction of acids with alkalis is neutralization. Okay. So when you mix an acid and an alkaline together, you're going to get some neutralization. It's probably going to stop the process. It's going to slowly slow down the process. All right. And then there's water is formed by chemical change. All right. And so acid and alkaline mixed together can create a heat. A lot of times you may say, I don't know why this client is burning. I don't know why this client is burning. You may need to go and check the pH of the products you're using, because if you use one product that had a high acidic level pH, and then you go use another product and it's probably on the alkaline side, yes, both of these two together on the same skin is going to cause a heating irritation. All right. It's going to cause something that is going on the skin. So a lot of times we're doing stuff and we're just not thinking far ahead, like, I really should know the pH of everything I use so I can stay within a suitable pH range. Okay. And a lot of times, if you're going to flip from one side of the pH to the other side, it's going to include water. Okay. And water is considered, take note, a universal solvent. All right. Adding water to something acidic and to something alkaline is going to reduce the strength of the product, right? And so that's, if you was to look at the pH scale, 7 would be neutral. What's neutral? Water. Okay. Water is a universal solvent. Add water to anything, it is going to dilute the strength of that product. All right. So you got something acidic on the face, just say a chemical peel is not doing what we needed to do. I'm gonna need you to take that sponge, you're gonna dip it in water. You're gonna take that towel and it's gonna be wet. Probably in cold. Then you're gonna put that sponge or that towel on the face. What does it do? Starts to calm the skin down, and that water component on top of that acidic acid peel on the face starts to neutralize the strength of that acid peel. All right. So it reduces the results that you're going to receive. And so that's what you look at. Water added to either side of the pH scale is going to reduce the strength of the product. All right. So whatever you're trying to achieve, adding water to it is going to calm that skin down and bring it all the way around. Let's look at physical change. The form is changed without forming a new substance. Examples: solid ice melts and become water. Okay, remember that solid ice melts and it becomes water. Let's look at our chemical change. A change in the chemical composition or makeup of a substance. The chemical change causes what we normally saw to be different. Now we see another substance, it produces something else. Example: burning wood is no longer a wood plank, but it turns into ashes. Okay. And ashes cannot turn back into wood. So it is a chemical change. You still know what it came from, but you'll never get wood again. Whereas on the physical change, if we freeze that water, we can get ice again. So you'll say, Ms. Cox, how would that relate to us and skincare? Once you have added that acid or alkaline product ingredient to the product, it's not, you can't go back in and take that out of it. It has now changed the whole component of the product, that one ingredient. Okay. You're not going to be able to go in and find the pieces of the acidic and take it out. Can't do it. Not going to do it. Pure substances and mixtures. Pure substances are distant properties. Okay. And when you talk about distant properties, it's mastered with a fixed chemical composition. All right. This is the ingredients. Then you got mixtures, elements combined physically. All right. Ingredients do not change their properties. They do what they said they're going to do. If you take concrete, that's a mixture of sand, gravel, and cement. The sand and gravel are held together by the cement. Okay. But they retain their identity and can be picked apart. You can tell the difference. There are solvents that'll break that back up. Pure substances, a chemical combination of matter in definite fixed proportions. We got some examples: atoms, elements, elemental molecules, and compound molecules. We look at distilled water, it results from the combination of 2 atoms of hydrogen and 1 atom of hydrogen in fixed proportions. Okay. Now, water is H2O. Okay. Water is H2O. Okay. 2 hydrogen, 1 oxygen. Distilled water results from the combination of 2 atoms of hydrogen and 1 atom of oxygen in fixed proportion. So that gives us what we see as water. Okay. That's what we know of today as water. And this is what I want. I'm going to put it in the chat. Water, aqua, is H2O. Okay. Hydrogen peroxide is H2O2. Okay. So water being a universal solvent, you'll find it as an element. These elements of 2 hydrogen, 1 oxygen that makes water. But H2O2 is going to be 2 hydrogen and 2 oxygen, very close to water, okay, but just has another oxygen element. You would say, Ms. Cost, what's H2O2? When you are doing your brow tint and it says mix 3%, 5%, or it may have a cream developer that says developer for you to mix, that is considered H2O2. When you're getting a hair color and they take the hair color, then they mix it with this white stuff, pour this white stuff in, that's H2O2. When you're getting bleach, you got your powder pack and then you got to get the developer and pour that in, that's H2O2. All right. And so the ingredients that really help change the structure of the color composition of hair is 1 oxygen away from water, H2O2. Here's what happens if you're at home and you have hydrogen peroxide on the counter, and just say you're going to do lash tinting or brow tinting, and you left the top off. When you leave the top off, first of all, let me just say, hydrogen peroxide has a 2-year shelf life, 2 years with the top on. If you happen to leave the top off all the time, you reduce how long that product can sit on the shelf. Over a period of time, without the cap being on the product, this product loses an oxygen. Okay, so it turns into water. And then you just want to go use it. It looked like something else, but in actuality, true form, it is now just water. It's just cloudy, milky water. And you think adding it to hair color now you're going to have a change? You're not going to do anything because you have allowed the hydrogen molecules and oxygen molecules to float away because the top was off. So the power of that product is gone away. Okay. I just wanted to show you that they are very, very close together, very similar. Okay. And so we're here with physical mixtures. This is our example of concrete. Concrete is a mixture of sand, gravel, and cement. Air is a mixture of gases. All right. So the air that we breathe is a mixture of gases. It's oxygen and nitrogen. All right. It's what we can't live without, oxygen and nitrogen. Let's look at other physical properties. And we're doing rather good at 43 slides. I want to get to at least 21 on here tonight and then jump back over to SEMA. All right, so looking at ointments, semi-solids made with any combination of petroleum, oil, and wax. It's going to be very important because we have ointments that we use. One of my favorite ointment is A&D cream. I use it on everything. Okay. Eczema skin, dry skin is a healing aid. And so that's one of the semi-solids. Add heat to it or put it in your hand and create friction, and that produces heat. You're going to get it changed into a more smooth. It's not going to be solid. It's not going to be semi-solid anymore. Okay. Heat will sensitize it and it will start to melt. And then we have powders, physical mixture of two solids. All right. Powders are a physical mixture of two solids. Free flowing powders are rarely found in cosmetics. They tend to stick together, such as tack, and are more common. We use powder in the practical of hair removal. Okay. We use powder in the practical of hair removal. Let's look at common ingredients. All right. Let's make sure I'm pronouncing. Okay, got to look at my stuff. All right. So let's look at volatile alcohol. It evaporates easily, such as isopropyl alcohol, which is rubbing alcohol, and ethyl alcohol, which is in hairspray and alcoholic beverages. Okay. Those are two different types of alcohol. All right. So these are common ingredients. Now, a lot of times people have wore out the word alcohol, and it gives you to put that cautionary facial expression on when someone says they're using alcohol. There are so many different types of alcohols, and you have some good ones for your hair, skin, and nails, and then you have bad ones for hair, skin, and nails. Okay. But there are some good alcohols that help stabilize liquid products. And so, especially when it comes to hair care. Now, we do know alcohol can pull out moisture. And so, when using these products and sprays, you know you will need to come back in with moisturizing, conditioning treatments. That's something you can even share to your hairstylist friends. All right. So, there's some good alcohols and there's some bad alcohols. Either way, they are going to pull out moisture. They're going to fight against moisture. They're going to get the job done, but they're going to fight against moisture. All right. Then there are fatty alcohol. Okay. Non-volatile oils that are used as conditioners. All right. So this is one of the good types of alcohols. Alkylamines. Hope I said that correctly. Alkylamines. Let's see. Substances used to neutralize acids or raise the pH of many hair products, often used in place of ammonia, which is a good thing. Okay. Substances used to neutralize acids. You will probably see this ingredient definitely if a company offers acid pills. They offer chemical pills, but they offer something called a neutralizer. Okay. They offer something, they say, hey, with our chemical pills, you have to use a neutralizer to make it stop working. And then some people will say there are self-timing or self-paced chemical pills, which means it'll go to its highest. And after a certain time, you'll see the chemical pills stop working. Okay. Alkylamines, substances used to neutralize acids or raise the pH of many hair products. So if you can add this, it can stop acid activation, or add it on the alkaline side and it could raise the pH of a product. You would say, Ms. Cox, how or why would you want to raise the pH of a product? I'm going to tell you. Okay. Just say you have a baby soft, gentle shampoo. It is only gonna be, it's not gonna be harsh on the hair. You may have to do multiple of these shampoos just to get the scalp clean. Okay. What if this person is a full grown adult with a full grown job that they're sweating a lot, accumulating a lot of dirt, oil, things like that on the hair, skin, and nails. I could probably add some aquamarine to my shampoo. It will raise the pH. When it raises the pH, the shampoo becomes stronger, not gentle anymore. So now the shampoo, without me having to do so many shampoos, maybe on the first to second one, it's gonna pull all that oil and dirt off. Okay. And so you got to know how to use it. And it replaces ammonia. A lot of ammonia on the pH scale is 14, y'all. It's the highest thing on the alkaline side. So using ammonia when you're cleaning, or especially on your hair, we don't want to use it on our hair, skin, and nails. When you are getting a permanent color, that ingredient has a form of pneumonia in it. Okay. When you are getting a permanent wave, or a Jerry curl, Gina curl, it has a form of ammonia in it. That's why it smells the way it smells. Okay. So we do have cosmetic products that does have ammonia, but you can replace ammonia with alkalamine. All right, it's going to take you thinking about it. And ammonia, it can make that product smell, make your hair smell, but y'all, it's too strong literally to be used on hair, skin, and nails. That's why they use it as a disinfectant cleaning ingredient. And this is why sometimes people cannot get permanent color, because their skin just may be so sensitive to the active ingredients, and one of them could be ammonia. So a lot of times we have to find out what's going on with our client's skin, and based on the ingredients of what we're doing, hey, we know exactly how it goes. Add water to it, it'll start to dilute. Okay. Glycerin. I love glycerin. All right. Glycerin, sweet, colorless, oily substance. Now let me give you this factor. I use glycerin. Okay, I took a class. In the class, I used glycerin to replace vodka, like vodka, alcohol, the strongest proof, like really, really strong alcohol. If I'm making a cough syrup or a tincture, something that's going to get rid of a cold or a cough, that you got the ingredients, you boil it all together, you pour it in a jar. The last thing you're going to do is add glycerin or vodka. If I add glycerin, this is now going to be a cough syrup for children. It's going to be sweet, and it's also take on the taste of whatever you had. So lemon and honey. Now I have me, if I let it sit long enough, I have me I have me a cough syrup that'll be sweet for children. Now, if I want something stronger to knock it out for adults, I will replace the glycerin with alcohol. Okay. And this is why you may say, my grandmama, granddaddy told me, make me a hot toddy, and they do this, and then they add alcohol to it, and I'm out, but all that stuff come up. Yes. Okay. Yes. They really do the same thing, but the opposite. All right. And so glycerin can be sweet, colorless, and oily substance. You also can add it to your serums, and it's like a stretcher as well. And then it's used as a softening moisturizer. So yes, I can add it to my color. I can add it to my shampoo. I can add it to my conditioner. All right. And what happened, it's going to give me more shine. It's going to give me a nice shine, and it's going to condition my hair. You have silicones, which are some key ingredients in, if someone is getting a silk press, you got an oil that you take out the bottom and put on the hair, and have a silicone base. Okay. Um, let's see who's on. It may have a silicone base. And even in your serums, glycerin or silicone may be one of your key ingredients, and then you add everything on top of it. Okay. Silicones can be used as hair conditioners. They're resistant lubricants for the skin. So you may say, okay, Ms. Cox, what product or can I use that I can add silicone to? And remember, it's water resistant. If you were creating a sunscreen and you were at the beach and going into the water, this will be amazing because that sunscreen will be protected, all right, against water. Okay, and you got some sun protectants that are not protected against water. All right. And then we have volatile organic compounds, VOCs, two or more elements combined, chemically compounds that contain carbon, okay, and evaporate quickly. All right, can go back up to alcohol, acetone, hairspray, spritzes. You spray it, dries fast. On this factor, we're gonna close out with pH, okay, and we got about, I'm gonna do three more slides after this. It's gonna cover potential hydrogen. Okay. The small p represents quantity, and the capital H represents the hydrogen ion. Okay. So pH, okay, is always going to be written with a lowercase p and a capital H. Okay. So one represents quantity and the other one represents hydrogen ion. We have something called the pH scale. All right. The lesser the number, well, first let's do the logarithm. They're in multiples of 10. So when you see 0, 1, 2, 3 on down to 14, it has about 10 steps in between. Okay. pH, parts hydrogen or potential hydrogen. That's what it is. So we call it, most of the time you're going to see this potential hydrogen, the pH scale. The scale is 0 to 14. These are just some basic notes for each scale. Okay. Um, and then the pH of 7 is neutral. Okay. This is what I want to say too. When you look at, some people may look at, oh, 1, 0, 1, 2. All right. It's not 0, 1, 2, guys. Remember, I told you it's 10 times in between. You multiply 10 times in between. Okay. So 10 times 10. So if you have an acid pill that says it's a 1, all right, or just say you have an acid pill that's a 2, and then you step down to 1, you have 1 being like 100 times stronger than 2. So I don't want you to relatively um think, oh, it's just one step 1 or it's just one step 2. I can use it on its client skin. All right. It's a long ways, it's a long drop. So the pH, even being one number away, could be a big difference on your client's skin. You're looking at 100 times. Okay. 10 times 10. Okay. And so the lower the number, the stronger it is. And if you look at water being 7, and you do have some acid pills, battery acid that's in the 1, 2 range. And if you go from 1 to 7, you got about 6, you got distilled water at 7, and then acid pill at 1, 1.5. You have about 600,000 times stronger than water, the acid pill. 600,000 times stronger than water. I just want you to get that for a minute. When we're looking at water being 7 and we look at ammonia being 14, you're looking at about 700 times, or I would say 6. Uh, yeah, 700 times stronger. Ammonia being 700 times stronger than water. So remember that one step up or one step down does not mean, oh, it's just one step away. It means 100,000 steps away. So going down and going up, the further the number is from 7 is strong. The stronger the product is on either side. So if you are 7 and it's water, and if that number is going lower, it's going to be a strong acid. And then if you're 7, which is water, and that number is going higher, it is a strong alkaline. So relaxers are going to be between 9 and 12 relaxers. Okay. And you have household bleach and ammonia at about 12 to 14. Permanent color, all of that. So all of that is strong stuff. But look on the acid side. If you said you saw an acid pill that said 1.5, because we do have that in 2, these acid pills are very, very strong. Okay. Very, very strong. In fact, our state law says that a 3.0 is really what we should be using. Okay. A 3.0, which is a 30 volume glycolic, that's really what they advise you to use. Anything lesser than that is going to be stronger. And so if your takeaway from tonight, if you didn't know, you just thought the pH scale was just kind of, oh, just one step up, one step down. No, it is serious times stronger, 10 times 10 stronger. We'll look at water and pH, hydrogen. Okay, hydrogen plus is acidic. Hydrogen ion, OH, is alkaline. All right. And so there won't be many components where you will need the chemical makeup or picturize what pH looks like, what acid and alkaline look like on the pH scale. So we'll do that with ingredients. All right, potential hydrogen and ions. It says the ion, it's an atom or molecule that carries an electrical charge. Ionation, temporary separation of a substance into ions. This is what I need you to study because you're going to come in contact with this. If anyone has a flat iron, you've probably already come in contact with it because with flat irons, some of them they work based on the ions that are on the hair. Okay. Or the component of the plate. It may be ion attractive or negative or positive. All right. And so that may be something extra for you to think about as well. It says potential hydrogen ions. The ion is an atom or molecule that carries an electrical charge. Ionization is temporary separation of a substance into ions. And an anion is an ion with a negative electrical charge, and a cation is an ion with a positive electrical charge. Okay. When does this come in effect? When you are using your galvanic machine and you're trying to do disincrustation, which in modern day, what does that equate to? A chemical peel. That's it. If you were a hairstylist, this would be an important factor because you will choose shampoos and conditioners that are ion negative or positive based on what you're trying to achieve with the hair. And most of the time, it's going to be how slick you want the hair texture, smooth, things of that nature. And then you will see it again on flat irons. Okay, add that added heat to it. It could change the ion from a negative to a positive. And So that in that component. Let's look at the next slide and we look at acids. Yes, the pH below 7. So acids it comes below 7.0. It turns litmus papers from blue to red. So I want everybody to understand pH. When I tell you as a beauty professional, you have to get this pH scale in your head. Keep one in your phone. We're talking about going to shows. You're going to be approached to purchase ingredients and things of that nature. Purchase products from different product cosmetic lines. You're going to get classes on alkaline acids, chemical peels, relaxers, all kind of chemicals, right? And you're going to need to know the chemical makeup. So you don't want to just purchase the product just off of a binge of, oh, it smelled good and it did well on this client and I'm going to get it. You have to look at your people and look at what you're able to actually do yourself. All right. And so if you understand acids and alkaline, it makes you having a better choice than just buying product and being scared to use it. And so if you look here on the acid going from blue to red, okay, we have a muriatic acid, lemon juice, vinegar, alum, peroxide, hair, skin, and nails, pure rain, distilled water. All right. And then distilled water is going to be 7, which is considered neutral. What we don't have on here is insertion of chemical peels. And so the chemical peels can go anywhere between this 0 to 3. And then you got enzymes that may also fall between 3 and 4. When you look at our alkaline, let me look at our alkaline side. You see baking soda, soap, depilatories, which is like we're talking wax products, we're talking Nair, those type of things. You're looking at ammonia and lye. So we're looking at cleaning products and relaxers. Okay, bleach is in here as well. And when you think of relaxer damage and think of Just for Me, remember that was targeted towards kids. It was a kid on the box of that relaxer because you thought, because as a kid on the box, it is more gentle and it's for kids, but it was the strongest product. Even the kid relaxer was stronger than the grown people relaxer. Look at Lie. And in some pH scales, you will see ammonia and lye switch. And so you just need to know, based on current facts or not, they're always going to wrestle between 12 and 14, which means they're still 200,000 times stronger than anything else, or 600 times stronger than anything else. So it's really, really strong, whether they're in the 12, 13, or 14 mark. Super, super strong. This is why some kids have permanent damage of hair loss and things like that, simply because the ingredients and products had faulty marketing and individuals did not know how to use it. Mismanagement and faulty information cause for hair loss when using chemicals of that magnitude. Alkalize, okay? Alkalinity is above 7.0. It goes from known as a base, and it goes from red to blue. Okay, red to blue. We're talking about acid alkali neutralization reactions. When we talk about neutralization, remember we have H2O. Okay, and so water is that 7. Water is going to neutralize all of it. Add water to any of these, it is going to make the ingredient weaker. It's going to weaken the strength of that ingredient. Okay. And I'm going to stop right there on slide 28. We'll pick back up on oxidation reduction. Okay. We'll pick back up on oxidation reduction. You guys may say, Ms. Cox, where can I find this? You can go into your Facebook group and you can go into files, search chemistry and you will see this pop up, and this is something that you can study as well. I do like it because it has a whole lot of details in with it, and so make this something that you just pin, and that you have a question on your study guide or something in your ebook that you don't understand, go back and maybe you can find the answer somewhere else. But I do love, sometimes we got to go back to these PowerPoints. It's still relevant information. It just has more meat to it, okay? More meat to it. So I do like that. So that's what I want you guys to just take a look at. Um, take a look at that. Okay. Let me go into and pull up our SEMA and see what we have. There's something I want you to start looking at in SEMA as well. Okay. Um, please hold on. I'm gonna share the screen. All right, so this is SEMA, our chapter 6, in our foundations. I want you to start watching the videos, okay? I want you to start watching the videos, and you can just open it up and you can see the videos, okay? So the first one will be basic chemistry. And from that video, come down to the pH balancing act. So I just want you to watch those two videos, basic chemistry and the pH balancing act. That'll get us to where we need to go for Friday. Okay. Any questions? Awesome, 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 awesome. Friday, we're going to do flashcards and we'll pick up on slide presentation from for Milady. Okay. So if you guys need anything, I'm working on hours tomorrow because it is the end of the month and I want to try to get those hours in early next week to the board. Okay. And so we got some student finishing up. They finished up this month, and I want us to close out all of those hours. So I'll be working on hours tomorrow while I'm at the hospital. But send me an email, and I'm catching up tonight and tomorrow on emails. I think Miss Richardson is coming out to help with the hours. So stay tuned. You'll be having an hour update next week, and we need to finish or really go deeper into chemistry. I may be bringing in some products for you guys to see on the Zoom so we can talk about some of your favorite products and the chemical component pHs of those as well. All right. So that's all I wanted you guys to do. I just wanted you to go into your Facebook, pull that down by going into files and then searching chemistry, and you're going to see that PowerPoint. Save it or do your own review. And then you're going to go over to your SEMA ebook, and you're going to come not ebook, it's your SEMA Chapter 6 Foundations, and you're going to watch some videos for me, okay? You're going to do basic chemistry, and then you're going to watch the pH balancing act. Those are two videos I want you to watch, and you'll be ready to roll on Friday, okay? Y'all have a blessed and amazing day. You know how to contact if you need me, and we'll be working on hours tomorrow, so just send me a message, okay?